Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine. Today I want to discuss about some mathematical problem which is very important for your board exam and also admission test. Our today's topic, integration, which is chapter number 10G. Now, mathematical problem. Our first mathematical problem is question number 41. Look at this. Integration of 4 tan cube x into sec square x dx. Here, lower limit 0 and upper limit pi by 4. And all we know that derivative of tan x is sec square x. So, let z equals to tan x. Therefore, dz equals to sec square x dx. And here x and z. Look at this. Here lower limit is 0. So x is 0, and when x is 0, then z tan 0. And we know, and here tan 0 means 0, so it will be 0. And again here upper limit pi by 4. Here z equals to tan pi by 4. Tan pi by 4 means 1. So here z is 1. Now we can write here 4 is constant, so it comes first. Integration lower limit here 0. When x is 0, then z is 0. So 0, and here x is pi by 4, then z will be 1. So we can write 1, and z equals to 10x. So putting z equals to putting 10x equals to z, so z cube. And here look at this part. For this part we can write dz. And now integration. Here z to the power 3, so it will be z to the power 3 plus 1, and here 3 plus 1, and here lower limit is 0 and upper limit is 1. Now 4 into here 3 plus 1, it will be 4, and z to the power 3 plus 1, that means 4, and lower limit 0 and upper limit is 1. Here 4 into 1 by 4, so it will be cancelled. So we can write z to the power 4 and lower limit 0, upper limit 1. And now putting here z equals to upper limit 1. So 1 to the power 4 minus 0 to the power 4 means 0. So 1 to the power 4 minus 0, that means 1 minus 0 equals to 1. Here this is the required answer of question number 41. Now question number 44. Integration of sin inverse x into dx by square root 1 minus x square, and here lower limit is 0 and upper limit is 1. Look at this. Here let z equals to sin inverse x. So dz equals to 1 by square root 1 minus x square into dx. And here x and z. Look at this. Here lower limit is 0. Suppose z equals to sin inverse x. here we can write sin z equals to x, and here when x equals to 0, then we can write sin z equals to 0. That means here x equals to 0 and sin z equals to 0, and we know that sin 0 is 0, so sin z equals to sin 0, sin 0 degree. That means z equals to 0, so here 0. And another one is upper limit is 1, so 1, x is 1. Here we can write x equals to 1, and all we know that sin 90 degree is 1, so sin pi by 2. Here theta, here z equals to pi by 2, so pi by 2. Now here lower limit is 0, so it will be 0, and upper limit is pi by 2, so we can write pi by 2, and z equals to sin inverse x, so z into z into here dx by root over 1 minus x square, so we can write dz. Now integration of z, it will be z square by 2, and lower limit is 0 and upper limit is pi by 2, and here we can write 1 by 2 z square and 0 pi by 2. Okay, now 1 by 2 here z square, so we can write pi by 2 whole square minus 0 square means 0. So our answer 1 by 2 into pi square by 4. So it will be pi square by 8, and which is the required answer of question number 44. Now question number 48. Integration of tan inverse x by 1 plus x square into dx. Here lower limit is 0 and upper limit is 1. So let z equals to tan inverse x. Therefore dz equals to 1 by 1 plus x square into dx. And here x and z. When x equals to 0, then z will be here z tan inverse x. We can write tan z equals to x, and here x is 0, so we can write tan z equals to 0, and all we know that the value of tan 0 degree equals to 0, so tan z equals to tan 0, therefore z equals to 0, so here it will be 0, and when x equals to 1, then z will be here x equals to 1, and we know that the value of tan 45 degree equals to 1, so we can write tan pi by 4, and here z will be pi by 4, so here pi by 4. Now here we can write 0 1, and tan inverse x into 1 by 1 plus x square into dx. And here when x equals to 0, then z equals to 0. And when x equals to 1, then z will be pi by 4. And here z equals to tan inverse x. So we can write z into, look at this, for this part, and here 1 by 1 plus x square into dx equals to dz. So we can write dz. And now integration of z, it will be z square by 2, and here lower limit is 0 and upper limit is pi by 4, and here 1 by 2 is constant, so it comes first, and we can write z square, here lower limit 0 and upper limit pi by 4, and now we can write 1 by 2, here z square. So putting the value pi by 4 whole square minus 0 square means 0, so it will be 0. And now after calculation it will be 1 by 2 into here pi by 4 whole square, that means pi square by 16, and here after calculation 2 into 16, so it's 32 and pi square, and which is the required answer of question number 48. Now question number 51. Integration of dx by x into 1 plus ln x whole square. Here lower limit is 0 and upper limit is e square. Now let z equals to 1 plus ln x. So dz equals to here 0 plus 1 by x into dx, that means 1 by x into dx, and here x and z. When x equals to 0, x equals to 1, when x equals to 1, then z will be, look at this, z equals to 1 plus ln x, and here x equals to 1, so we can write ln 1, and for this value is 0, and 1 plus 0 it will be 1, so here 1, and another one is e square, upper limit is e square, so we can write z equals to 1 plus ln e square. So we can write here ln e square. So 2 comes first and ln e. Look at this here, ln e means 1. So 1 plus 2 into 1. So we can write 1 plus 2 equals to 3. So when x equals to e square, then z will be 3. Now we can write here 1 e square and 1 by 1 plus ln x whole square into 1 by x into dx. Now when x is 1, then z equals to 1, so we can write 1 here e square. When x is e square, then z will be 3, so it's 3, and 1 plus ln x equals to z, so it's z square, and for this part we can write dz, so it's dz, and here integration of z inverse 2 dz, and lower limit 1 and upper limit is 3. Now after integration it will be z inverse z to the power minus 2 plus 1, and here minus 2 plus 1, and lower limit 1 and upper limit is 3. After calculation, minus 2 plus 1, it's minus 1. So minus, and here z to the power minus 2 plus 1, so it's minus 1. And here lower limit 1 and upper limit is 3. So we can write 1 by z, 1 and 3. Now after this line, here minus 1 by 3 minus 1 by 1. Okay, minus 1 by 3 plus 1. After calculation, it will be minus 1 plus 3. That means 2 by 3. Which is the required answer of question number 51. Now question number 58. Integration of x into e to the power x square into dx. Here lower limit is 0 and upper limit is 1. So let z equals to x square and dz equals to twice x into dx. So therefore 1 by 2 dz equals to x dx. And here look at this, here x and z. When x equals to 0, then z will be 0 square means 0. So here 0. And when x equals to 1, then z will be 1 square equals to 1. That means 1. Now here look at this, 0 1 e to the power x square into x dx. And here when x equals to 0, then z will be 0, and when x equals to 1, then z will be 1, and here x square equals to z. So we can write e to the power z into, look at this, x into dx. Here x into dx equals to 1 by 2 dz. So we can write 1 by 2 dz. Now here 1 by 2 is constant term, so it comes first. 1 by 2 integration 0, lower limit is 0 and upper limit 1, and here e to the power z into dz. Here, and all we know that the integration of e to the power z is e to the power z. So it's e to the power z, and here lower limit 0 and upper limit 1. Now we can write 1 by 2, here e to the power 1 minus e to the power 0, and here e to the power 0. E to the power 0 means 1, so our answer will be e minus 1. 1 by 2 into e minus 1, which is the required answer of question number 58. My dear students, no more today. See you again in the next class.